In this lesson, we'll look at how to solve quadratic equations by graphing. So in this example, we're asked to approximate the roots of 0.5x squared minus x minus 0.5 is equal to 0 by graphing. So if we graph the function y is equal to 0.5 times x squared minus x minus 0.5, and then we solve for the we look at what the x-intercepts of this function are. Those are the values of x that make y equal to 0. So if you think about it, the x-intercepts of this equation are going to be the solutions to this equation, because to solve this equation we're asking what values of x make the left side of this equation equal to 0. And if you were to solve if you were to try to figure out the x-intercepts of this equation algebraically, you would let x be equivalent to 0, and then you'd solve that equation, and that would give you the x-intercepts of this equation. So we can just graph this equation, look at the graph, and figure out what the x-intercepts are, and those x-intercepts are going to be the solutions to this equation. So we can graph y is equal to 0.5x squared minus x minus 0.5 by completing the square and rewriting it in vertex form. So the first step to doing so is to look at your a coefficient and factor that out of the quadratic term and the linear term. Thus you get 0.5 times x squared minus 2x minus 0.5. We leave the constant term outside of the bracket. The next step is to take half of minus 2 and square that, and then we're going to add it and subtract it to produce a perfect square trinomial. So we'll have 0.5 times x squared minus 2x plus 1 bracket minus 1 square bracket minus 0.5. Now x squared minus 2x plus 1 is a perfect square trinomial. That factors to x, that factors to x minus 1 squared. And now I can get rid of the square brackets by distributing 0.5 into these square brackets. So I'll have 0.5 times x minus 1 squared minus 0.5 minus 0.5. I got rid of the square brackets by multiplying x minus 1 squared by 0.5 and then multiplying negative 1 by 0.5 as well, where I use the distributive property. Now I can simplify this. I can combine negative 0.5 and minus 0.5 to give me minus 1. So I'll have 0.5 times x minus 1 squared minus 1. Now the vertex to this equation, the vertex is 1 comma minus 1. The step pattern from the vertex is 0.5 comma 1.5 comma 2.5 comma 3.5 and etc. We'll probably only be able to fit a few points on this on the grid that's been provided based on how it's been scaled. So first we'll start by plotting the vertex. The vertex is located at 1 comma negative 1, which is right here. This point is 1 comma negative 1. Next we'll follow the step pattern. So we go over 1 up 0.5, which is this point, over 1 up 1.5, which is this coordinate, and over 1 up 2.5, which is this point right here. We can reflect all these points about the axis of symmetry, which is the vertical line passing through the vertex. And lastly, we'll draw a smooth curve through all these points to plot our parabola. That's not very smooth, but that's okay. Okay. So now that we've got our parabola plotted, we can look at the graph and we can say, what are the x-intercepts of this function? So the x-intercepts of this function, well, this x-intercept is approximately 2.4, comma 0. This x-intercept here is approximately negative 0.4, comma 0. And again, I'm just approximating what the x-intercepts are. So from the graph, the roots of this equation are negative 0.4, approximately, and 2.4. So I can write out from the graph the roots are x is approximately equal to minus 0.4 and x is approximately equal to positive 2.4. So you can see that you can solve the equation, or that you can approximate the roots of the equation 0.5 x squared minus x minus 0.5 is equal to 0 by graphing y is equal to 0.5 x squared minus x minus 0.5, and then estimating what the x-intercepts are from the graph. So that concludes this lesson, and we'll see you in the next video.